Okay, when resistors are arranged in parallel, okay, this is how we can find out the sum of the parallel resistors. Okay, so you take the reciprocal of the actual resistance of the three different ones, and you add it up, and that's your resistance. Determine an expression for the total resistance RT. That means to isolate RT, so first of all, let's combine these three expressions. So what we need to do is the common base is R1, R2, R3. So up here, we need to put R2, R3. Same here, R1, R2, R3. So on the top, we need R1 and R3. Everything but the R2. Here R1, R2, R3. So on the top, we need R1 and R2. So R1 over RT then is, and then all possible pairs. Okay, so RT then will be the product of all three resistance over the pairs. Okay, determine expression for a total resistance if R1, R2, R3 are equal. So for part B, then RT will be just R1 cubed. They're all equal. So it's R1 squared. So R1 squared, but there's three of them. So 3 R1 squared. Okay, so we're going to get R1 reduced with up here, so you get just R over 3 or R1 over 3. Determine the expression for the total resistance if R1, so here I'm just going to do part C here, R1 is double of R2, which is 6 times R3. Okay, so RT, okay, so I'm going to replace R1 with R2. So 2R2, 2R2 for this R1. I'm going to leave R2 as R2 and R3 as a third. Okay, actually, you know what? To avoid fraction, we can change everything to R3. So R1, which then change to 6R3. R2 is 3R3 times R3. Okay, so R2 and R3 will be just this. R1 and R3, we'll be multiplying these two. And R1 and R2, okay, R1 and R2, right? So this is R1 and R2, so it's going to be 18R3 squared. Okay, this is also R cubed squared. So here you get 9 plus 18 is 27R cubed squared. That's 18R R cubed, okay, 3. So that will reduce to give you 9. Actually, divide the top and bottom by 9 to get 2 over 3 times by 1 over R3.